Welcome to episode 18 of the all-wheel drive Mustang project, Project Traction. Well, once again, a lot of great progress. I mentioned in the last video that I was moving on to finalizing the oil pan design. But that basically got curtailed or got transformed into working on the front CV axles. I realized before I could finalize the oil pan, which is a pretty complicated part, I needed to know what CV joint, or at least how it was going to interface with the jack shaft on the driver's side of the car. And that all interacts with the steering and a whole bunch of stuff. And so I had to finalize that CV joint. And that's what this video is actually going to cover, is the front CV joints. So there's a lot of detail here, a lot of exciting progress, so let's get right into it. So I realized before I could actually finalize or fully develop the design for the oil pan, I had to basically finalize the diff position and make a decision on the jack shaft and how that interacts with the CV joints, right? So my outer CV joint is already pretty set in stone and is kind of driven by the fact that I'm using, you know, a rear Mustang hub. I got some new ones here. And so this is a nice size CV joint meant for the rear of a Mustang, which slides right in there, right? But I'm using a Toyota differential here on the passenger side for the front diff, and I need something that plugs into this. And I've had many concepts of how to do that. This is the factory part that plugs into there, that basically snaps in. And if you go back a couple of years, I pondered taking, this is a old used Porsche 930 style joint, and it doesn't take much imagination to think you could make an adapter to bolt that on, but they're rather big and they don't have much travel. They only have plus or minus 8 millimeters of travel. They do make versions of this that are plus or minus 20, but I'll get into that later about the travel. But basically, these don't have enough travel. This is the joint I used in my Merkur project, which is a Volkswagen size joint, which is 100 millimeters, and the Porsche size are 108 millimeters. But then after deciding to use the Mustang outer joint, I thought to myself, why not use the Mustang inner joint too? And so this is the inner joint from a, you know, S550 Mustang. Obviously this shaft here is massive, but one beauty of it is that it is not a tri-lobe or, you know, style CV joint. It's actually, in this case, an 8-ball plunging CV joint with quite a bit of travel, but maybe not quite enough. But I still really liked the idea of using this joint, right? And so, but with enough imagination, I could imagine machining this away to make it plug directly into the Toyota differential. And so I did a little practice. Actually, Harold and I did all this, my buddy Harold, and I'll show some details of this. I know I'm jumping to the answer here, but basically, here's what you get, right? I took one of these, and Harold and I machined it, and ended up with that, and which then plugs directly into the differential, not needing any kind of adapter. And so that seems like the way to go. But after kind of jumping ahead and making this, I realized, well, that doesn't solve the other side, the driver's side. I need to basically have a jack shaft that plugs into this differential that goes through the oil pan. And I don't have an ability to make female splines, right? So there's no way I can take one of these and then couple it, you know, to a male spline coming out. And so I did ponder, like, you know, cutting a section off of a existing CV joint and, you know, welding it onto here. I even kind of played around with that for a couple of days, but this is so hard. I was just really concerned that the weld wouldn't be good, and I just didn't like the idea, to be honest. So then I went down the dangerous path of searching the internet for a joint that looks like this but has a female spline, right? So after lots of Google foo and looking around, I basically determined that you're going to laugh at this, but this is the CV joint from the passenger side of a 2005 through 2010 or so Jeep Commander or Jeep Grand Cherokee. And I stumbled upon that it's a similar joint. But what's crazy is it's not just a similar joint, it's the same joint. This is also, these are made by NTN in Canada, I believe, but either way, North America, and so are these. And besides, it's a little bit longer, they are exactly the same joint. Matter of fact, all the parts are interchangeable. The race, the spline on the shaft, everything is exactly the same. This just has a little bit more travel, which ultimately was very fortuitous because it realized I need a lot of travel. And so this part here ended up just being practice. And so what I did is I got, this is the passenger side from a Jeep Commander, and then I also then got the other side, the driver's side from a Jeep Commander, which has a male spline similar to this and has enough stock to machine, down to also replicate this spline to plug directly in. That way both sides would match, right? I'll use this on the driver's side, and I'll use basically the Jeep equivalent of this part on this side, right, to plug directly in. And that just all came together so nicely. What's super funny is that all these parts are the same. This is the shaft from a Jeep Commander, and here's the shaft from the back of a Mustang, and this is identical. Well, this is the opposite side, but it's the same spline. The parts interchange everything. Not that that's actually very important, that the inner spline or the inner CV joint and the outer CV joint are from the same company, but I just found it so kind of funny and interesting. But anyways, so now that the plan was set in stone, I procured a male Jeep Commander CV joint and then proceeded to modify it to look kind of like this. So let's get into that. The first step in making the Jeep Commander / Grand Cherokee CV joint work with the Toyota front differential is turning down the profile of the CV joint to match that of the Toyota stub shaft. And of course the axle or CV joint is already hard, but with the appropriate carbine tooling it goes quite well. It machines very, very nicely. It was making nice chips. Yeah, they're a little hot sometimes, a little blue, but it actually left a very nice surface finish, so everything went quite well. The OD of the CV joint actually ran pretty true to the bearing and sealing surfaces of the original Jeep CV joint, so it was just a matter of putting it into a 3-jaw chuck and then using the center on the other side and a live center in the tailstock to keep everything concentric. Here I'm showing again trying to put a fillet radius between a couple steps in the diameter. This is basically a full radius carbide tool, and it worked. Once again, it worked very well. The trick here is that you potentially are making a really huge chip, and so you have to kind of sneak up on it, do a little bit on the outside, a little bit on the inside, but as you can see, it made a really nice fillet, and it should reduce any stress risers between the different diameters of the CV joint. What's interesting here is you can quite clearly see how the end of the existing Jeep CV joint is not heat treated. Obviously the splines that have now been machined away were induction hardened, and the end was not. And so the hardened section actually machines much easier as I've kind of already said, it leaves a nice surface finish, whereas the soft end, which is kind of gummy, was leaving a very rough surface finish. Luckily, in the final product here, after I cut it to length, that section, that unheat treated section, it gets cut off, so it's really not that important. It's more of a curiosity. Here's the Jeep CV joint after being fully machined or turned. It's now ready to be splined. The splines will go right here, and then this is actually the, it'll be cut off right here. But I want to keep the center on it, so when I put it on the mill for putting the splines on it, I can use the center to keep everything straight. But as you can see, it turned out pretty nice. The surface finish, when the material is hard like this, it actually ends up with a better surface finish. I used some hardness files, and I'm still somewhere about 55 Rockwell on the surface here where the splines are going to be. And based on cutting this slot here, the depth is easily deeper than the splines, which is actually proud of this surface. So the should be plenty strong and fit in the Toyota differential. After resplining the main shaft of the transmission, I decided to up my game a little bit and bid and won an auction for this laughably oversized CNC indexer. But once you get used to having this, there's no going back to a manual dividing head. It really makes things a lot easier. More importantly, it makes it less stressful because you're not going to miss a step. It isn't actually hooked into the CNC machine. You have to hit the button every time, but it's still much easier than a manual dividing head. Here's the stub or the CV joint after the first pass. Really, the first pass was 3 passes, but I purposely kind of left it fat, if you will. It isn't as deep as it should be. I'm going to do an over pins dimension and then do a calculation, and then we'll do another round to try to sneak up on the final dimension. Like I mentioned in my video about resplining the main shaft, you don't want to disturb this setup, so how do you measure this to ensure it's going to fit on the female spline? Well, it's the over pins dimension is the best way of doing that. So I'll measure the over pins, do a calculation, and do some more cuts. So here's the part all done after many passes, but the passes are much less nerve-wracking, if you will, with the automated indexing head versus using the manual machine. What is a little frustrating is how as you start approaching your over pins dimension and trying to really sneak up on the dimension to make it fit, it gets more and more touchy as you get closer to it when you're trying to match the factory splines. Early, when you're really far away from the dimension, you can take 10,000ths, do a bigger depth of cut by 10,000, and it seems to make very little difference in the over pins dimension. But as you get closer, it gets more and more touchy. So, for example, this part didn't fit, and my over pins dimension was 6 or 7 thousandths big. I added just 3 thousandths to my depth of cut, and now it's actually a little sloppier than I would like. Is it going to work? I think so, and I'm not going to redo it, but it's just, I got to, lessons learned here is probably should do a cleanup pass before changing any dimensions as you get closer, kind of a spring pass before, and measure the over pins again before making any big changes as you get closer to the dimension. But it's going to work. It's probably just a few thou undersized relative to the Toyota spline, and it'll work. I'm going to send it. Lastly, I put it back in the lathe with a steady rest and cut it off, faced it off, and put a center back in case any additional work had to be done in the future. So now that I have a inner CV joint that actually plugs into the differential in the front of the car, I plugged it into the differential and basically I took an outer Mustang CV axle and put it in the spindle and cut it off to length, and then put the suspension in basically its shortest position, where the axle would be in its shortest position, and then cut the two to length. And now I'm going to make some kind of tube to go in between these two with some screws, to be able to have an adjustable length CV axle. Not only to make sure this is all going to work, but also determine long term when I make new custom axles how long they should be, to ensure there's no binding and everything's going to work out properly. I made a little adjusting tube out of some simple 1-inch black pipe, put it in the lathe, cut it to length, and bored it out to be a reasonably nice fit to the OD of the existing CV axles. Now I got it opened up so that the shaft is a nice sliding fit to make my kind of mock-up variable length CV axle. Finished part after welding on some nuts for some screws. Maybe I'll put some set screws on it, but now I can have an adjustable length CV axle. So here's the basic idea. So with these screws, I can basically have an adjustable length CV axle. I'm trying to verify what length I need and make sure there's enough travel in the inner CV joint to take into account the turning of the wheel, the vertical suspension travel, and the fact that when you turn the wheel, this goes through an arc and really sucks the axle back and forth. So, but I realize that I really want these boots off so I can see the position of the CV joint. So I'll take them off and then put it back in the car here. So now that I have this all mocked up, I'm going through all of the range of motion, basically moving the rack back and forth and going up and down through the suspension travel to make sure I have enough motion in the inner CV joint. It is actually pretty close, in a sense that there's having enough travel on this inner joint, but it's going to work. It's on the edge, but acceptable. I can always limit the travel or increase my ride height a little bit. But it does show that moving the diff as far forward and as high as possible will help the situation. So as I'm redesigning the oil pan, I'm pretty sure I can move it forward at least a 1/4 inch, if not 3/8, and move it up probably 1/8 to 1/4 of an inch. All these things matter, but the basic mock-up CV joint, really helped the situation. Here I'll give you a better idea of the range of motion. So I basically disconnected the tie rod and got rid of my jack so I can move it by hand. And you can see how much travel there is because of the steering. The fact that the CV joint isn't in the center of rotation. It really, with the dual pivot front suspension, you can see how it goes through the range of motion here, how it really needs a lot of travel. So you combine that, right? So if I go to basically in this case, turn to the right and then lift it up, you can see how I'm using up all of the travel. And, so getting the CV joint length right is going to be extremely critical to get this to all work out. But I'm pretty happy with my CV joint selection. I think it's going to work, and well, I gotta make sure that's staying in there all the way. I think it's going to work, and so now I can move on to finalizing the oil pan. Well, that's a wrap on another episode of the all-wheel drive Mustang project. Hope you found this interesting. I think what really surprised me was how much travel the CV joints are going to have. Obviously, the stock front suspension of the S550 Mustang was never intended to have a CV joint, and so they didn't design the pivot point to minimize travel if there was a CV joint in the hub. But it's going to work out. I got super lucky with that Jeep inner joint, which has even more travel than the rear Mustang one. And so I'm more confident than ever that it's all going to work. But I appreciate you watching. What makes these videos fun for me is actually all the great questions and comments, so please leave them below. And I hope you like and subscribe. Until next time, thanks for watching.